Okay, as Liz mentioned, I'm going to be speaking about an ongoing project that we're doing, a collaborative project that we're doing at the amazing cathedral in Cologne. An amazing site and well worth visiting again and again because it's such a spectacular building. But before I get into that particular project, I want to address another project that coincidentally has occurred in advance of this. I was recently in Egypt as part of a British Council delegation dealing with Egyptian heritage under threat. And it was an incredible event and very similar to the UNESCO presentation yesterday of the dangers of looting and destruction of sites, vandalism, but very well organized. And Egypt has particular issues with a very porous border, so people can come in and out quite easily. And the amount of heritage in Egypt is unbelievable. And the result is that a lot of this stuff is going on to the black market. Now it was a nice arrangement because there was a British delegation and then an Egyptian delegation. And the Egyptian delegations were speaking about real issues with concerns about the sites that they're dealing with. The profound problem that they have is the lack of tourism or the collapse of tourism. So that has an impact on heritage sites and the money that goes into the heritage sites, legitimate money. But one of the comments that came up, and it was originally told to me in Islamic, and I can't pronounce it properly, so I won't even try. But one of the Islamic sayings is that people who lose their past lose their way. And that's been a very motivating statement for the people involved in archaeology in Egypt. So, moving forward slightly, I'm just going to begin the presentation on the Cologne Cathedral. A spectacular building, and amazingly enough, began construction in 1248. This unbelievably huge building was designed almost designed and then initiated almost 6 centuries ago. And I just couldn't imagine a structure this size being around in the 1200s. It was finally completed in 1880, so it's this weird kind of construction and the stages of construction that have occurred on that site, which makes it quite unique. From 1880 to 1890, it was listed as the tallest building in the world at 157 meters high. And in 1996, it was added to the UNESCO World Heritage List. Now, like many cities in Europe that had to deal with the ravages of World War II, the cathedral knew that it would be under threat, so it went to great lengths to defend itself in terms of its architecture and also its the artifacts that sat within it. This is quite interesting. This is their bunker for sculpture and stained glass to protect the materials that were within the cathedral. Very sad story about how they had to remove the artifacts, the stained glass, and put them in here into this building. But nevertheless, despite their precautions, the building was struck 14 times during the war, but didn't collapse. And one of the speculations is that the reason why the cathedral stood up throughout World War II was it was actually a turning point for the Allied bombers. So the destruction, though, of Cologne was profound. The cathedral, recognizable as a building, but nevertheless received quite a bit of damage. It's sitting right next to a very significant rail station, so that was a target. And then when the Allies went into Cologne, the building itself received direct fire, and you could still see the remnants of World War II on the facade of the building. But what is more interesting to me in terms of the heritage component is the contemporary threats that the building is under. So you're looking at issues of urban encroachment, a very significant issue also in Egypt, that urban encroachment and urban development is a bigger threat than terrorism in terms of some of the people that are on site there. With Cologne, same issue with urban development, tall buildings going up near the cathedral. But more current events. This is the Cologne archive that collapsed in 2009 and 2 people died. In this situation, it was an issue of undermining, and the archive isn't that far from the cathedral, and it was due to the construction going underneath Cologne that caused, I believe, a water pipe to crack, which then brought down the ceiling, and the result is that the archive collapsed. And sadly, you know, a lot of the stuff that was destroyed was stuff that was well protected during World War II. More recently, in May, and this is just when we got back from the scanning, quite a sizable bomb was found in the river. It was far enough away that it wouldn't have affected the cathedral, but nevertheless a massive bomb just sitting in the silt. So on to a more positive note, the elegance of the Gothic Cathedral at Cologne, an amazing building. I mean, the physical presence of it and the size is overwhelming, but then the detail that exists on the facade and then on the interior is really incredible. And the volume of the interior is massive. So what I'm presenting today is a work in progress. It's going to be a multi-phase project. The first phase occurred back in May, and the challenge is to comprehensively document the building to the best of our ability. So using terrestrial laser scanners, all with built-in HDR cameras, to document the very, very architecturally busy cathedral. In particular, the buttresses are quite a challenge, and then some of the tighter space that exists around the cathedral. And then, of course, the 2 towers will be a particular challenge. Now, one of the things, additional challenges to the cathedral are global warming, acid rain. You know, it's an urban center. The type of stone is porous, and the result is that it can be quite frail. And the result is that the cathedral is, you know, replacing components over time. And in fact, they have over 120 craftsmen on staff just to service the building, repairing previous damage, and then also adding or replacing current stonework. So I would like to talk about the first phase of the project, which was a very unique project. And I gotta say, it was similar to a certain extent to the Scottish 10 project that I was involved with years ago when I was at the Glasgow School of Art working with David Mitchell. It was a collaboration or a collaborative effort. So we had a number of organizations involved, both the cathedral, and I'll just bring up the project partners here. And so these 4 main groups got together to do this project. And it made my life fantastic during the time. Tremendous support from the cathedral, tremendous support from the University of Applied Sciences, and I'm going to get into that in a minute. Of course, the City of Cologne. And then also we were very fortunate to pressure, I guess, ZNF scanning company to provide us with equipment. And I would say that they were more than enthusiastic in terms of supporting us on the work. So the team that we had on site was both, students were involved as well as professionals, and in particular, these are the main people that were involved in the project, and I'd like to point out 2 in particular, both named Chris, who are sitting in the back. Maybe if you want to wave, Chris and Chris. So Chris Wickenden was the one who initiated the project within Cologne. We met in Karlsruhe about a year ago today, and he asked, you know, if you were to scan a building in Germany, what would it be? And I've seen the cathedral before, and I said, you know, the Cologne Cathedral, not expecting it to be actually a real project, and he made it happen. So it was fantastic, and then at the same time contacting ZNF and saying, this is a fantastic project that's on your doorstep, would you like to be involved? And they went out of their way to support us. So you'll see a lot of blue scanners, the ZNF 5010C, And it was a great piece of equipment. It was perfect. And I want to say I've been involved in scanning for almost 8 years now. And the evolution of the technology is increasing so much that the return of the data is always impressive. And also the supporting software. David Mitchell mentioned this as well. You have organizations like Leica with their Cyclone software, which is fantastic for registering. You have Autodesk coming out with things like Recap, Recap 360, Memento. So the world is really engaging with scans and scan data. So the 2 scanners working full-time, and also using, rating the ZNF cabinet of equipment. So we have a lighting system on the scanner. This particular scanner is a short-range, kind of high-density scanner. But the reason why I particularly like it for heritage is that it has an HDR camera which is built into it. And it's nice to see the guys from NC Tech in the other room, because they have a similar system which is perfect for heritage. I love scanning and I love the scan data, but the next level up is beautiful HDR, multi-station or multi-level photography embedded in it. So one of the challenges in the interior of the cathedral is the lack of light. So that's why we use the special camera system, and that will be calibrated to the movement of the camera. Some of the imagery from the camera. And for the first phase of the project, concentrated on the interior at grade, so the big volume of the cathedral, all the way around the exterior and certain parts on the roof, and then up into the attic area of the cathedral. So that's the outside of the domes. And this incredible steel superstructure which supports one of the towers. And then the vaults. And one thing that we played with, and this is where I do see scanning as being progressing again and again, is that you're not necessarily restricted to the XYZ point or the reflectance from the point. You could overlay data, photography, HDR photography being the first thing to come in there, so that gets overlaid very nicely. But you can do other things now with different sensors. And in this situation, a thermographic sensor, and we're just kind of playing with it up at that level in the cathedral. So all the scans went from, in that area, consisted of the scan data, the HDR photography, and then the thermographic imagery. So this is all the raw data. I should say where we are with the project right now is that the first phase, all the data has been registered, it's all tied together. The next phase will involve further data and then a lot more processing. So just to give you a sense of that's a view from the roof. And then one thing that kind of worked is putting a scanner on a cherry picker. And I said kind of worked. I haven't interrogated the data yet to see if there's, there will be subtle movement with the cherry picker, and one of the kind of goals of this project is to provide, a definitive copy that's perfect. And so, but the nice thing is that we're able to use the scanner and operate it remotely. And just to give a sense of the size and the scale of the cathedral, you could see the scanner way up along the vault there. So that is an issue. One thing that did work well was the camera within it. So that's the vantage point. And one thing I want to point the attention to, you see the walkway with stained glass. That will be part of the second phase of the project. One thing that I particularly enjoy doing is looking at the scanner as more than just a static tool that sits in a vertical way. There's ways you could position and reposition the scanner to put it into areas that you couldn't go to measure. So in this situation, you notice the vaults that exist on the inside. There's particular points in the vaults with keystones. So they remove a couple of plates and they're able to open these up. These are huge, it's a huge drop. Oops, sorry that. So there, in this situation, we have a special rig that allows the scanner to be lowered down. And again, this is with Chris, lowering the scanner down so that we can then get a perfect view, a vantage point. And then Chris held operating the scanner remotely. And it was incredibly stressful when we did this. You know, there's a lot of energy in the air. We're lowering it down. It's a very expensive scanner. It's a very expensive cathedral. You don't want anything to go wrong. Everything has been tied 3 times over. And so you could hear this energy in the room, and then we're communicating with people below who have, you know, made sure that no one's underneath it and the area is safe. Absolutely no effect whatsoever, because it was this tiny little blue dot that appeared in the ceiling, and so you could barely see it. So just some of the scan data that we got from the project. And some of the color imagery. I just want to fly through some of these next ones. So this is kind of a snapshot in time of where we are. This is the scan data in Recap Pro. And I'm purposely showing it simply because you could see the black areas where all the buttresses are. And that's a challenge for the next phase of the project. Because of the architectural complexity, you have to put the scanner in a variety of different positions to fill in all those missing areas. So the grade level scanning went perfectly, of course. The interior scanning went brilliantly. Just some of the resulting CAD drawings, stations. So in total, 220 scans and 9 billion dimension points. And then some of the data from the roof in terms of the imagery. And then some of the scan data. So this is just a sample. This is the point cloud, and it's just so beautiful and dense, but also the combined imagery is fantastic. And this literally has been kind of brought together simply for renderings to show off the first phase. So because it's a work in progress, once we finish the second phase, this will all be kind of taken apart and we'll put everything together. And, you know, at some point the data is so dense that it looks like a photograph. Now, one thing I wouldn't say cheating, but what I am showing you is beautiful data of the ground level, and that's where we had the scanner the most. So the next challenge with the project is the towers and the roof levels, because we have issues with the extent of this particular kind of scanner, approximately 50 meters, so everything above that, the data begins to dissipate. So the next phase will be using scan systems to address that. This is a particularly beautiful rendering from the scan data. And also the interior was all done. And again, great results from that. So, and this image there, you can see how the cathedral, the tops of the towers are off. Now, one thing to point out, you'll notice that kind of box structure on the side. We have access, or I have access to the Cologne Cathedral rigging team, and they're responsible for the maintenance, setting up scaffolding on the building. So we'll be working together to create particular kinds of scan rigs. I love scan rigs. We use them at Mount Rushmore, we use them at Rani Ki Vav in India to position the scanner in areas that will be a challenge. So as opposed to scanning straight up or like that, we're going to be inverting it, and the result is that you get the data, a different kind of data. And the one thing I think is important about doing this, although it's a trivial thing, you know, I mean, the idea is, the concept is really basic, but if you look at a building, what are the surfaces that are damaged or destroyed over time due to weathering or pigeons? It's the flat surfaces that are pointing at the sky. So those are the surfaces that I particularly want to capture with the work. And been using this when I was part of the Scottish 10, but then also more recently at St. Michael's Mount, use that quite a bit because of the very aggressive terrain that you have there in Cornwall. And then at Durham Cathedral, that was scanned last year. And just a simple image on the left is the top of the tower of Durham Cathedral, and that's from the scanner at a parapet height, and that's probably about 30 meters, but at angle. So you could make out the stonework, but you certainly don't get any detail. Whereas when the scanner is inverted on the right, you do pick up a lot of the damage to the stone. And in terms of the ultimate, so the next stage is next week. Actually, no, on Friday, I'll be there with both Chris and Chris to be working on the project. Chris with his university and Chris from ZNF, working side by side to look at the areas along the parapets, up on the roof, up on the towers, and really looking forward to the project. Now, the data itself, at this point, the challenge is just to get it as comprehensive as possible. The delivery of the data, all the data, and this is from going back to the Scottish 10 days and being, so motivated by Ben, is that the data belongs to the cathedral. It doesn't belong to Harriet Watt. We give it over, and then they carry on with it. So, it can be used for 1,000 purposes, of course. But, everything from 2D CAD, 3D BIM, photorealistic modeling, monitoring purposes, 3D printing, mesh. What we're going to be looking at it from Harriet Watt is we have a very strong structural engineering department, and I have to say I was very much impressed by the previous presentation on the Taj Mahal. So we'll be looking at finite element analysis, and in fact we put in a research application with Horizon just to focus on that particular task. And also, we've been engaging with the University of York to do 3D acoustic analysis. And they were up in Scotland just recently with us talking about how they could use the 3D data to do acoustic studies. And of course, the big thing will be, it'll be an archival record of the cathedral as it is today. And that will be, hopefully, very soon part of the CyArk archive. Thank you.